Good day, my name is Richard and a warm welcome to Tutoring with Richard, where we cover the South African school syllabus and related topics. If you find these videos helpful, please consider supporting me on PayPal, Patreon or Buy Me a Coffee. Links in the description box below. Today we're going to cover Strength of Materials in 6. The topic of this tutorial is a mixed bag of possible exam questions, round 2, question 3. The formulas used are included in the video. The question is also posted in the description box below. We have been asked to issue a cautionary note. Some of the formulas used in these videos, which are taken from DP examinations and past papers, do not appear in most textbooks or the formula sheet attached to your exam. You will need to know them in order to do some of the sums. They appear in the beginning and end screens. Let's get straight into it. Okay, our first question, our question states, a simply supported beam is 4 meters long and carries a uniformly distributed load of 12 kilonewtons per meter over the full length of the beam. Young's modulus for the material is 207 gigapascals and the stress in the beam is limited to 80 megapascals. The deflection is not allowed to be more than 1/360th of the length of the beam. So let's put down our information. L is equal to 4 meters. Young's modulus is 207 times 10 to the 9 pascals. The UDL, the weight, the small weight, is 12 times 10 to the 3 newtons per meter. And also we have the stress. The stress is 80 times 10 to the 6 pascals. And the deflection, I will draw both symbols for deflection. I'm going to draw both symbols for deflection. It's Y or capital delta. Now that is 1/360. Okay, the first thing they want us to calculate is they say select the lightest parallel flange I section for the stress limit. Okay, so first what we're going to do is 1, 1. First thing we're going to do is say M is equal to WL squared over 8. Because we know this is a parallel flange. This is M of a parallel flange of I section, only I section. If it was a channel, if it was a H section or something like that, it would be a different formula. But right now we're dealing with only I sections. Right, so M equals 12 times 10 to the 6. My mistake again. 12 times 10 to the 3 times 4 squared over 8. This equals 24. M equals 24 times 10 to the 3. Okay, so M Alright, next part, Z. We want to find Z. Z equals M over stress. So 24 times 10 to the 3 over 80 times 10 to the 6. And that equals 300 times 10 to the minus 6. That is Z. Now we're going to deal with ZXX. So we need to look at, Z on the XX axis. So that will be, we're going to look at that, and that will be the closest one to that, the closest I section closest I section is 305 times 102, 24,5. kg per meter. Now, what this means is that the 300, so you take this number that you get here and you find the closest number possible. They want the lightest. So don't go for the next one down, go for the actual lightest. The real number for this is actually the real Z for that particular one is 286,4. So the real I is the real Z, sorry, the real Z XX is 386, 6,4 times 10 to the minus 6. Okay, now that we've got the lightest of this one here, this is to do with the stress. Next we have to do deflection. So, we're going to write okay. Okay, question 2 is 5WL4 over 384 EI. Okay, that's the formula. Equals delta or Y, whichever one you choose you can use. Now this is 1 over 360 equals 5WL4 over 384 EI. Okay, now we want I as the subject of the formula. So 1, so I over 360 equals 5WL4 over 384 E. Now what we need to do is multiply by 360 on each side. So I equals 360 times 5WL to the power 4 over 384 E. Okay, so I equals 360 times 5 times 12 times 10 to the 3 times 4 to the power 4 all over 384 times 207 times 10 to the 9. Which equals 6,9,57 times 10 to the minus 6. Meters to the 4th power. Now, our hot roll tables will tell us that the closest mark to that, now the closest I-beam equals, the section equals 305 times 102 times the closest section that is 32,8. 32,8 kg per meter. That is the section that belongs here. So 305 times 102 times 32,8. Right, so what we've learned, now the next question number 3 is select the correct I section used and state the reason why. Okay, we need an I section that can satisfy both of our limitations. Okay, this is our limit, this is our stress limit, and this is our deflection limit. So, what can be done? So, the closest one to both is I section 305 times 102 times 28,6 kg per meter. The reason why is that this can satisfy both. This I section can satisfy both of these, because if you're going one or the other, but if you do both at the same time, this one will do best. And you will write that. They ask for a reason, so you write out the reason. It satisfies both limits. It satisfies both limits. Right, now 1,4. We take that one's, the 28,6. 305 times 102 times 28,6. Right, now what we need to do is the last thing is calculate the actual stress and deflection in the selected beam. So, the actual stress in the beam, well, we'll know the actual stress soon enough, which is stress equals M over Z. So, it is 24 times 10 to the 3 divided by Z, Three, 5, 2, 1, 3, 5, 2, 1 times 10 to the negative 6. Yes. And this will equal our stress. So it is 68,162 megapascals. Now for our last piece is we're looking for deflection. So 5WL4 over 384 EI. This is the actual stress. Now we're going to do the deflection. So the deflection goes 5 times 12 times 10 to the 3 times 4 to the power 4 all over 384 times 207 times 10 to the 9 times I I is 54,31. 54,31 times 10 to the negative 6. Okay. And this will equal, okay, now over and under, this is 3,558 millimeters. If you found this video helpful, please consider giving it a like and subscribe. It really helps with the channel, with the algorithm, and to grow the channel. Positive feedback is most welcome. I enjoy reading your comments. Please use the comments section to let me know what topics you'd like me to cover in upcoming videos. Be at peace, be kind to each other, and remember, passing well is achievable. Have a great day. Looking forward to seeing you in the next video.